just cannot afford it. Okay, it started, so let's get it out of the way and trying to go through the problems. And the first problem is that the integral coordinate x, y, and y are selected such that 0 less than x, 0 less than y less than 5. How many distinct value of m are possible if the graph of the equation y equals mx pass through the point x, y. So this type of the problem, you just have to literally draw a picture, and because one picture was 1,000 words. Let's try to do it. So it's in the first quadrant, so we can draw it like this way, and then we count 5. 1, 2, 3, 4, 5. That's the x. So this is 1, 2, 3, 4, 5. That's 5. Then here is 1, 2, 3, 4. 1, 2, 3, 4, 5. So 5 is here. And then the x is greater equal than 0 and less equal than y and less equal than 5. So see, it's an integral, means that both x and y has to be integer. So it's on the grid. It's on the so obviously, and x, y equal is satisfied. So basically, these are the points that satisfy. And then we will try to pick number, like this is 1 and 2. So 1, we kind of just trying to list the equation and it works. So this is 1 and 2 coordinate works. And also like 0 and 1 work. So basically these points are all the point working. And so we kind of just had to do the casework. And even include this one, because 0, 0, and let me see. Oh, yeah. And so basically, we kind of just color coding it. Obviously, this is on the vertical line. And vertical line, basically, there's no, in the format of this. Vertical line, this one is actually x equal to 0. It's not in the format of y equals mx. So these 5 lines, basically, these 6 dots. Let me try to admit. Yeah, it's here. Yeah, so these 1, 2, 3, 4, 5, 6. These 6 dots do not produce any of this format. Then let's try to see the first row, first column. So this. So this basically is obviously, y equals x, y equals 2x, y equal to 3x, y equal to 4x, y equal to 5x. So basically we have like 1. So m is from 1, 2, 3, 4, 5. We got 5 value for the first column. And so that was settled. Then on the second column, 1, 2, 3, 4, we will see that. So this is like, 2 and 2. And passing through 2 and 2, still y equals to 1x. So this actually already covered by the first line. So we do not count this. And this is basically the slope. The slope is rise over run. So the rise is 3 and run is 2. So basically m is equal to 3/2. So basically this point, so produce this number. It's a new one. So we recognize it. And this one obviously do not produce a new one because it's actually, this point is called 2 and 4. So basically it's going to be like, m equals 2. And this one is m equals to 5/2. So basically at the second row, so we have 5m here, 2m here. And here, basically this point still going to be the same, m equals 1. And this one, basically the rise is 4, run is 3. So 4/3. And this one, run is 3, and rise equal 5/3. So basically we produce 2 new m here, 2 new slope. And here the rise is 5, run is 4. So this is 1 here. And the last point basically is already shared by this. So basically if we add all those cases together, it's going to be 10. So that's, how many distinct value? The answer is 10. I didn't really check the answer, and I think, if I'm wrong, just correct me. And this is just, how I would do it. And so this one is like, the typical speed problem. Typical speed problem, you have to introduce a 1. So basically a special 1. If you introduce special 1 as total task, you will be able to solve this problem fairly easily. Total task. And so Toby mowed a lawn in 15 minutes. Working together, Toby and Nick takes only 30 minutes to mow the same lawn. How long would it take Nick to mow the lawn alone? So here we introduce 1. 1 is the whole lawn, the same lawn we repeatedly mowing it. And so we use the formula. So RT equals W. W is the work. And so we still produce a 4 colon, like this is the cases, and this is the rate, time, this is the work. And the work is 1 in all the case. And Toby can mow the lawn in 15 minutes. So Toby, cases Toby alone. And so Toby alone, and its time is 15 minutes. His mowing rate is 1/50th. So in every minute, he finished 1/50th of the whole lawn. And then Toby and Nick, so they together, so T plus N, together, and take only 30 minutes. So 30 minutes do the same lawn, and their speed is 1/30th of the lawn. And then it's asking how long would take Nick. So Nick alone, and Nick alone, basically, their combined speed is actually the speed of Toby alone and Nick alone. So basically we kind of do like 1/30th. So here, basically it's 1/30th minus 1/50th, and 1/50th, and it's like 150 is the LCD. So here is the 5. We scale to 5 to get this. Then we scale 3 to here. So this is 2 over 1/50th equal to 175. So this is 175. This is still 1. So this is going to be how long it would take Nick to mow the whole lawn. So that's 75 minutes. So because this is 175, so here is actually 75. Does that make sense? Just trying to get some feedback.
Yeah.
Okay, great. And let's try this one. And this is what is the area of the right triangle bounded by the graph of. So basically it looks like, this is the vertical, this is y-intercept, so it must be quite high. So we change our view from ruler line to the grid line. So we're going to draw this. And this looks like it it goes down. So it's look like the picture is going to focus in the first quadrant because it's just starting from very high at 12 and going down. So we will draw it like just draw the first quadrant of the picture. And so we count 12 because the y-intercept is 12. This is origin, 0 and 0, and this is x, and this is y. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12. And bounded by the graph of this, and this is the slope. Slope, the bottom is run. This is the right. So run 3, descend 2. So this is run 3, down 2. So 1, 2, 3, 1, 2. So this, so you can just repeatedly doing this, and then you pretty much is able to like find the spot. And looks like the ratio between this and this is 2 to 3. So this is 12 to 18. It must be 18. You actually can count. So it is 3, 6, 9, 12, 15, and 18. So basically, the area of the right triangle is like 12 multiply 18 divided by 2. And we can cancel one of them out. 6 multiply this going to be, and 108. So that's the area. And I didn't check the answer. If I did any thing wrong, just let me know. And so this one is that what is the length of the graph? So this is the linear algebra problem. Draw picture is the key. You have to draw the accurate picture. If you draw the accurate picture, mostly speaking, half of the problem is solved. So what is the length of the graph, within first quadrant? So the first quadrant, it looks like starting from negative and it's ascending. So we can draw the picture like this way, focus on the first quadrant. So this is the origin, so 0, 0, and it go down 8. So 1, 2, 3, 4, 5, 6, 7, 8. So this is the y-intercept, 0 and negative 8. And so here is the slope. Slope, this is the run, this is the rise. So it's run 3 and the rise 4. So basically I go 1, 2, 3, rise 4. 1, 2, 3, 4. So that's the point. And run 3, rise 4 again. 1, 2, 3, 1, 2, 3, 4. So I actually got those 2 points. And it's asking the length of the graph that within the first quadrant. So the first quadrant, basically, if I connect the dot, it's the length of this segment. And this is actually, 6, 0. So basically, this is a 3, 4, 5, like right triangle. So basically, this is just, because this is 2 multiply 3. The length of 6 is 2 multiply 3. This is 8. Here is 2 multiply 4. So here is just 2 multiply 5, going to be 10. So basically 10 is the answer. And let's do this problem. And so Kenny is playing on the mall escalator. He can run up the down escalator in 30 seconds. So basically the escalator is moving down this way. Actually, the escalator is moving up. He is running down a up escalator, has to take 30 seconds. And taking 6 seconds to run up the up escalator. He run up, oh, I'm sorry. He run up the down escalator. Escalator is down, yeah, he run up. So basically he is going against it, taking to run up the up escalator. If the escalator is going up, then he is is 6 seconds. So this is 30 seconds, this is 6 seconds, and the how many seconds would Kenny to run up the flight of the stair. So basically this is just the same flight, the same floor, and so it's the how long it's going to run up the flight, and also so basically we are facing actually two speed. One is the escalator speed. Escalator could go up and down. Going up, we assume that the escalator rotating down or rotating up, it's using the same speed. Basically, we have to make that assumption. Otherwise, there are too many speeds to be, tackle with. It's impossible to solve it. So then we have so escalator speed. We will say it's the speed is. Right now we are dealing with the second. So basically, we not necessarily have to set the speed. We can set the second. It's okay. So basically, because it's asking how many seconds would take Kenny to run up the flight of the stairs. So basically, I will say that because it is 30, this X, this is X. And there's another speed that you have to consider, because that's actually, if you stand still on the escalator, how long it's going to take to carry it up the flight automatically. So you can set that to be Y. And I think in this case, I would use different letter, because escalator and the stair speed, it more makes sense just using a different letter system. So basically this is the stair speed. And this is the escalator. And so basically we will trying to see that how would we tackle this? And this is the, let's assume speed instead of the time, because if we assume the speed, we actually get reciprocal, because speed, we can, the advantage of the speed is speed, you can actually, add a subtract in terms of to get the, differential speed. So basically, this is the stair speed. This is the escalator speed. And obviously the stair speed is faster. Otherwise, if you running up a down escalator, you will never reach the top. You will just always stay at the bottom. So basically, we know that stair speed is bigger than the escalator speed. So let's go with so it's still going to be RT equals D. And again, this type of the problem, you don't know, it didn't give you the length of the escalator and the, size of it. So we always use a special one. So the distance is just one. It's the one flight. And we use the fraction to deal with this problem. And so if we build a 4-column table, it's very easy to do this. RT, D, and D is going to be always 1. And because we assume the speed, so basically, if this is the running up the down escalator. So basically I have to, the rate is actually the stair speed minus the escalator speed. That's the rate. The time used going to be 1 over S minus E. So that's the time. And this actually is equal to 30 seconds. So basically that's what we got from here. And then here again, we assume the speed, so we can add a speed is stair speed plus escalator speed. And then we still facing with the work volume of the one stair. Then the time going to be is 1 over S plus E. equals to 6 seconds. And so right now we are trying to solve this equation. And so it's just, this is a fractional equation. We just to cross multiply. It's just equivalent to 30/1. So basically 30s minus 30e is equal to 1. And this is just, 6s plus 6e equal to 1. So here, basically, we can do the scaling to really, we can scale this. Usually you label the equation by 1 and 2. So basically is 2 plus or 2 multiplied by 5. If you scale up by 5, you can do addition and subtraction. You can actually cancel the e. So basically 2 multiplied 5 equals to 30s plus 30e equal to 5. And then if you do the addition, this adds this, going to be 60s equal to 6. And the s equal to, so basically this is 10s equal to 1 and s equals to 1/10. So basically, the time used going to be reciprocal of the speed. That's 1/10 of the stair. So the time, so basically here is the, up, the down escalator. This is the up escalator. And this going to be just stair, walking up or running up the stair. And so the stair speed, we actually find it. So basically it is actually 1/10 and the time going to be 10 and it's still going to be 1. And the other one basically we can just, do a different way. Yeah, so this is actually, this is not 3e, this is 30e. So we can use subtraction. So basically this multiply 5, we can, this is positive, this is going to be minus this. So basically if you do a minus, this 3 minus 1, you will get this s will cancel and this going to be 60e going to be equal to 4 and equal to like 1/15. And so basically e going to be 1/15 and 15 and 1. Yes.
So why would 30 s plus 30 e equal to 5?
Oh, just 2 multiply 5.
Wait, why would you multiply it by 5 then?
Oh, I multiply 5 so that I can synchronize the coefficient between 1 and 3. I can do the addition and subtraction.
Okay.
Yeah, this is the way to solve the equation system is that if you're going to try to find the common, least common multiple. The least common multiple between 30 and 6 is 30. So it's best to scale up this one by 5 in order to enable this calculation. Does this make sense?
Yeah, I understand.
Okay, great. So let's try to do this problem. And this problem is more like a bullshit problem, but I'm kind of just showing you how to do it. It's really just counting the letter. It's basically, obviously this looks like on the surface it's very difficult problem because obviously the letter are priced differently because one is for $2. These are 3 letter, and 2 is for $3. So basically each letter in this combination has a different price. And we don't know. And if you really add them up, there are so many variables, there are not enough condition. But we really try to construct it this weight is at like 1 is for $2, is that right? And 2 TWO is for $3, and 11 is for $5. So ELEVEN is for $5, and 12 TWELVE is how much cost. And we would trying to, match the letter one by one against. So these are the letter we need to buy. We color it here. T, W. W is here, and E is here, and the L is here, and the V is here. Another E is here. So basically, in order to buy this, we just need to buy TWELEV. So basically, we definitely need to pay 3 plus 5. And here basically is, but we have we already have all those letters. In addition, we have ONE. ONE is the extra. So for example, if I buy those, they're set. Then if I can sold the extra one to somebody else, then basically I literally paid $6 because it's 3 plus 5 and minus 2 because I can sell back the extra one to someone else. So that's $6 will be cost for neighbor. And I think I only see one of the problem like this, so don't worry about it. This problem is too much bullshit, and really, I don't think you can easily invent any problem like this in another situation. Okay, so let's keep on going to do the next topic. And today we're going to cover a lot of things. And we're definitely going to cover the Vieta theorem, Vieta formula. And so that's one of the important things that we need to go through. So let's get started. So the last time, let's see, is a harmonic, mode digging, whole linear equations, system of equations, ratio, we already did that. Distributive. Yeah, last time we reached here. So distributive property. And distributive property is quite simple. There are not much things to it. I think it's just the main result is that you have to remember the FOIL. The FOIL, I think everyone already know it. FOIL is just if you have a binomial, multiply another binomial, you don't have to go through the middle step. You can go from here to here directly. This is first because A and C are the first term. A and D is out. B and C is inner term product. This is the last term. You are able to file it. And then here comes the famous difference of square. You definitely need to remember this. This is just special case of the FOIL. The middle, it only has two terms. It's just the first and the last. In the middle, outer term and the inner term cancels because outer is negative AB and the inner is plus AB. They cancel each other out. So that's where this comes about. And so it being widely used, you definitely need to be remembering this. And then here comes another famous one is perfect square. To check the perfect square, for example, you just have to make sure the first term and the last term is a perfect square by itself. This is 2x. This is square. This is 3 square. And if you can verify the middle term is 2ab, this is 2 multiply 2x multiply 3 is actually equal to 12x. So this is a perfect square. It's equal to 2x plus 3 square. Just those problems are quite simple. I'm not going to go over it. You can practice on it. Then here comes the sum of reciprocal. So reciprocal problem is actually used a lot in the Vieta formula, and trying to calculate the reciprocal of the root given the given knowledge on the sum of the root and the difference of the root. Sum of the root and difference of the root can be calculated using the coefficient of the quadratic equation. So let's try to see the quadratics. So quadratics, and I think maybe formally, I think maybe only Sharon has been really studying it, because her grade really covers that automatically, and it could be a difficult problem for other students if you haven't really touched it. But I'm going to go through it very quickly. I also will going to point out in every case, if you have difficulty remembering the formula, going to get you through all the troubles. So first we need to know that, so basically, in the linear equation, it's like y equal to mx plus b. So this is a binomial. And then this is the standard form. So standard form of quadratic is just adding a quadratic term. And then also the A, B, C don't have the special meaning as here. M is the slope. There's no slope here because a quadratic function actually represent the parabola, and in the parabola and the slope going to be changing every spot. So basically it's not going to have a fixed slope. So this is just is a quadratic. And quadratic, there are several ways to manage the quadratic. One of the thing is factoring. Factoring, the importance of the factoring is that once you are able to factor the quadratic, you actually automatically get a solution of the quadratic equation. And we're going to go through a few examples on how to factoring it. The easiest factoring is the GCF. GCF means that, if you can find any common factor between all the terms, just pull it out. For example, here is not even a full trinomial, it's just a binomial. We find out that for x is a common factor, it could be easily factored out. So that's the way we deal with this one. Then also special case that, if the first term of the quadratic term's coefficient is 1, it's easier to factor. It's called monic. One the first term is 1, it's called monic. So this one is like a monic quadratic quadratic polynomial, then you are able to factor it into this format. The key to factor it is that, the constant is the product of JK, and the linear term is the addition of JK. If you are able to achieve that, you're able to factor it. Let's try to really quickly factor this one. For example, I can factor that 2 multiply 9 equals 18. And if I put, because this is negative, if I put negative sign on -2, and -2 plus 9 equals to 7. So I successfully factor this one. I'm going to go very quickly and not going to linger on the. So Another case is the perfect square. So the perfect square, you kind of just has to really, match each term, make sure it's a perfect square, then and find out the root of the each term. Then if the middle term happen to be 2ab, then it's a perfect square. For example, this one, the quadratic term is 7x squared, and the linear or the constant is 9 squared. So basically, 2a, 2 multiply 7x multiply 9 is actually 7 multiply 9, 63, and 2 multiply 63 is actually 126. And it works, and we just need to use a minus sign because 81 could be like, 9 squared or -1. So this one is actually equal to 7x minus 9 squared. So I can just do the perfect square this way. And the difference square is just, again, you kind of just find out its perfect square. If the sign is negative, you can factor out this way. These are the easy ones. Then we're going to go through the harder ones. And the harder ones, let's try to do the harder ones. Let me clear out some garbage and begin with the harder ones. For example, this is a harder one. This harder one is at 6x squared minus 23x minus 18 equal to 0. How are we going to factor this? And given this type of the situation, because if you have monic one x squared, plus like let's say b x plus c equal to 0, then you just factor c and make sure the two factor will add up to b, then it works. If you find those, it's not monic. This is so you are trying to factor not this is c. It's the trick is factor ac and make sure the two number factored out can add up to b. So here we actually has this, and 6 multiply 18 equals to I think usually it's the best to use the factor it out rather than multiply it up, because it's not much useful to find everything that up a big number. So you can multiply 3, multiply 2, multiply 3 square. This is basically equals to 2 square multiply 3 cube. So basically this is the one AC. This is AC we need to factor to get this number, negative 23. And so basically, and you can just list them out. So basically, first, obviously everything is, because you already factored it out, it's fairly easy to walk through this step. So if every factor, if it's 1 on one side, everything is like, multiply 2 square, multiply 3 cube, then basically this is actually 108. And so obviously 1 plus minus 108 cannot get you 23. So that actually is out of the way. Then the next way to factor, if you just put in a 2, the rest of it is 54, still not getting it. Then you can up the scale 3 and the 36. 3 and the 36 still not getting it. And then the next biggest factor is 4 and the 27. And because this is a negative, so we actually trying to factor the negative 2 square multiply 3 cube. So basically 2 square is the factor, the remaining is 3 cube. So basically that's very easy to figure out. And that negative, and because we are trying to get to negative 23, so basically this actually is, we find a successful factoring. So this is a successful factoring. After finding successful factoring, how are we going to deal with it? So basically, um, basically 2 has to be on the diagonal because they actually going to be multiply. So basically 2 and 2. So you lay it out this way. And because why 2? Because the because there actually there's a easy way to do it if you use this format. I actually use this format myself. I say it's like a quadratic fish, look like torpedo or whatever. So you can actually fill in those numbers. So basically here we actually have a you can double check it this way. This is going to be A, this is going to be B, this is going to be C. So basically A is 6, B is negative 23, and C is going to be negative 18. And we already know by factoring this out that, so this colon, this vertical line has to be 2 and 3. And because we have to make a 4 diagonally here, we have to make a 4 here, so that's 2. And we have to make a diagonally negative 27, so that's going to be, has to be negative 9. And this actually multiply up to negative 18. So everything, so this line need to line up to 6. This line need to multiply up to, and this line need to be multiplied to 4, because 4 and negative 27 is the one that satisfy the condition of getting to this. And so basically we're using those tricks, we are able to, solve this problem. And then after you successfully factor it out, basically this one is just 2x minus 9 and multiply 3x plus 2. So this is the way they factor it. And so that's the ways of factoring. And you have to remember that not necessarily every, actually majority of the quadratic equation is not factorable. And what's the condition of, it could be factored? It actually, there's a special thing you need to check. Even before you go on this adventure, you better to check if it's factorable or not. So there's one thing that you need to know is that it's called discriminant. Discriminant is actually b squared minus 4ac. And b squared minus 4ac is the discriminant. You can tell if this quadratic is factorable by checking this number if it is a perfect square. So right now, we actually is able to factor it. I can guarantee it is a perfect square. I can bet money on it, and I'm going to always win. So basically, the b square is just 23 square minus 4, and the a is just 6. And C is just, you have to including the sign. So actually B squared is should be negative B. And but B squared, since it's square, you're going to, the sign wouldn't matter. And for A, C is actually negative 18. So this number will be a perfect square, I can guarantee it. So basically, let's try to calculate it. You know, not going to spend too much time. I'm going to just bring up a calculator. So going to be 23 square, let's see, minus minus going to be plus. So this is 24 multiplied 18. Okay. So plus 24 multiplied 18 equals 900. And this one is actually 31 square. So basically, if I trying to do the square root, is actually equal to 31. So basically, this has to be a perfect square in order for this to work. So these are the ways to do those quadratics. Then let's go to the quadratic formula. I think, other than Sharon, for the rest of you, I think we'll just, knowing the trick of remembering this quadratic. Because if you haven't studied the quadratic formulae, and if you are in the AMC10, and the best way is just use the quadratic formula, because, they are factoring perfect square. There are 3 methods to solve. But, the other 2 are not always guaranteed to solve the problem at all. And the quadratic formula is guaranteed to solve any problem, even if it has a imaginary solution, you're still going to get it. So basically, let's just to remember this. So the trick to remember is able to tell a story, is that this is called negative y, a negative y is wondering about. Wondering about means just positive and negative. A negative y is just negative b. Is wonder about going to a radical party. A radical party is just radical sign. It's the square root sign. Radical party, and then inside the party. So this is the inside the party. He means the negative y only talk to a square boy. A square boy is just b square. So, and ignoring 4 Olsen checks. So for AC, just for Olsen checks. Then the party is all over at 2 a.m. Is all means that everything is, above the fraction line, and under the fraction line is 2a, is all over at 2 a.m. So basically, if you're able to remember this story, you're able to recite this formula accurately. So if you're able to recite this formula accurately, you will be able to solve any quadratic equation without any hesitation. So basically, I think, well, most of, if you are in the, so with this formula, the only thing you have to worry about is just move everything in the right position. For example, you cannot use the formula directly because it's not in standard form. You have to move everything to the right side. So basically x squared minus 4x minus 7 equals 0. Then basically, a equals, and the best is that if you use the formula, just write out all the, the parameter a equals 2 and b equal to -4 and c equal to -7, then you are able to solve this problem. And so this is the solving the quadratic equations. And then we actually has a lot of Vieta. So Vieta is actually a very famous saying, and it's used a lot of in the test and computation. And we kind of just, we kind of also, I also copied the definition from Wikipedia just for you to get familiar with the formula. And the formula actually runs deeper than the quadratic equation. And I'm also going to prove the quadratic equation. And so basically, I'm going to prove the quadratic equations Vieta using the formula. So basically, first, let's just see how the Vieta formula works. It looks like this kind of, jumbo like garbage, and you cannot really understand. But we are going to skip this and going to the real example first. And in the real example, in the quadratic polynomial and also into the cubic polynomial, then we also going to go to the quadratic. This is a quadratic polynomial in the real example. Then we're trying to go back to this formula so you will understand the whole thing. So the Vieta in a quadratic polynomial, basically the standard form is ax squared plus bx plus c. And in a cubic polynomial is a cubed plus b x squared plus cx plus d. And this is a quadratic. A quadratic is just, ax to the fourth plus bx to the third plus cx squared plus dx plus e. So basically, these are just, so let's trying to see, the pattern, how the pattern goes. R1 and R2 is its root. So the sum of the root equal to negative b over a. And the product of the root R1 and R2 equals c over a. So this is for the quadratic polynomial. And then these are the cubic polynomial. So basically, if it has a root, then root 1 plus root 2 plus root 3 equals negative b over a. And then here is the product of the root. Here is actually the product of two of the root. Because here it's quadratic equation, you only have two roots. So product of two of the root is just all the roots. So basically here is just a special, but it's not that special. So basically it's just, when you reduce to two quadratic equation, it's just reduced to two, but it's actually a wider concept. It's just, the total of the product of any two root is c over a. C is actually the, the third position parameter over the first position parameter. And this is the product of the all roots. So basically it's negative b over a. So you could see that start from negative and positive, then negative again. This is negative, positive, so it's alternate. Then this is the case for the quadratic. So the quadratic, I collect a real example. So for example, how does it work? How does it work? For example, this we have a special case. Basically, it's monic. It's monic means that the coefficient of the highest is 1. So basically, if that's the case, then basically, for example, negative b over a is equal to, because 1 is just 1, is actually negative b, because a equal to 1, a equal to 1 in this special case. So basically, if we do just a number, use this example here, it's just, all the root, the summation of the root, if it's monic, it's going to be a negative negation of the first term, coefficient. Then basically AB plus AC and A, B, C, D, these are actually its root. So they are 4 roots. The summation of the two root product of any combination, add all of them together, and you have to include every possibility. So it's actually equal to a positive of the third position coefficient. Then basically this is the product of any four or any three root will add to the negation of this, and then the product of all the four will be this. So this basically this is a Vieta formula goes a long way. So basically actually goes to any power. So let's go back to this. So this basically what does this mean is that if you have a this is generic form is that go to all the n. So basically this is the if it's an nth power polynomial, then this is the leading term. And the leading term is at a n and x to the nth, then plus a n minus 1 x to the n minus 1 all the way to a0. A0 is a constant term. And then all the roots added together is the second leading term, the negation of second leading term over the leading term. And then this is just, you know, all the possible way you make product of two roots. A1, R1, R2, R1, R3, all the way to R1, Rn. This is R2, R3, R2, R4, R2, Rn. So basically, you know, any way you can make product added together is equal to the, here is a negation, there's no negation. Then the next one, so it's alternate, negative, positive, negative, something like that. Then finally, the product of all the root is going to -1 to the nth power, a0. A0 is the last one over am. So that's the way that, you know, this is just the Vieta formula. Then how do we interpret this is just, you know, so this actually will expand into this a group. And 1k, so k can go from like all the way from 1 to 1 to n. And so basically then this is the pi. Pi is the product of everything. And this is sigma. Sigma is summation of everything. So it's the summation of the product of the subproduct of k root. So k from 1. So one root basically is this special. K, 1k equals 1 is this formula. 1k equals to this formula. K is to the m, basically a m minus n equals a0, then it's the last formula. So basically, you know, this will expand to this. So if you study math or if you're dealing with higher grade, like, you know, the formula, you eventually will hit this. I kind of just gave you a fresh view of this. Then for the quadratic, we actually going to prove it. And prove it also help you to really remember this, you know. So the Vieta formula, we're going to prove it on the quadratic term. So we're going to use the quadratic formula. Quadratic formula states that x1 equal to like negative b. Negative y is wondering whether or not going to a radical party. In the party, he talks to a square by ignoring false and checks, and the party is over at 2 a.m. So the first root basically is the second root basically, you know, so the first root is a positive. Uh, let me, yeah. So the first root is positive. The second root basically is a negative. The second root Why it stopped change? I don't need the eraser. That's annoying. Let me close it and reopen it. So that's quite annoying. So right now it should be gone. Yeah. So right now it's should. So the first root is the second is negative b minus and b squared minus 4ac over 2a. So basically the summation of, so if you add those two roots, because this is by formula, this is how it works. So x1 plus x2 is actually equal to, remember these are positive and negative, those will cancel out. So basically it's actually equal to negative b over 2a plus negative b over 2a, because the other part is just going to cancel. And so basically it's negative 2b over 2a, and equal to this cancel is negative b over a. So that's actually, you are able to use this to prove it. Then we kind of x1 multiply x2. x1 multiply x2, notice that they actually have, it's actually in the form of a, let me use the a plus b multiply a minus b. So basically a going to be equal to negative, a actually equal to b, a actually equal to negative b over 2a in this case. And b actually equal to square root of b squared minus 4ac over 2a. So basically that's, so x1 minus x2, using this formula, if you observe, if you find this observation, is actually should be equal to a square, so negative b over 2a square, and minus b square. B square, so basically is square minus 4ac over 2a square. And this is going to be equal to 4a square and b square minus, so this is 4a square and b square minus 4ac. And this we actually b and b cancel. So basically this thing going to get to like 4 negative negative going to be positive 4ac over 4a. And we a cancels for, this is a square. So a square just 2a. 1a cancel, and 4 is actually equal to c over a. So basically, under using the quadratic formula, you actually is able to prove the Vieta for this special situation. And so that is actually very, very useful. So we're going to go through some, so you don't have to remember the formula, how's, you just need to, you only need to remember the quadratic formula. Quadratic formula, given the story, actually, given the story, you should be able to remember it. And then if you forget the Vieta, then you actually is able to derive the Vieta from the just quadratic formula alone. And in case you forget about it, the summation is really easy because obviously they cancel negative b over a. And because they cancel, and the leading part are going to double. So this part obviously going to double because you have to add two roots together. So that's going to be, it's negative y over 2am. Negative y over 2am is actually also a very, negative y over 2am is actually, double root. Sometimes this part is 0, you have a double root. So this is actually the double root. If you have a double root, that's going to be this case. And if you have a double root, then the summation of the root is twice the double root. Twice the double root is just b over 2a, or b negative b over a. So it's very easy to remember. So just tell you that how I remember it. I remember this formula by the story. Then this formula tell you the special case on the double root is negative b over 2a. Then twice the double root is just the summation of the root. Then the other part is also easy to remember is c over a. C over a, because this is negative b over a is just, sum. Then the Vieta states that, the next to each other, it's actually, it's negative 1 over k. So basically the sign of the summation of different level, it's just going to be flip flop as you. So basically, if this one is negative, the next one need to be positive, and the next coefficient on the, so you on linear coefficient on the top, then you have to go to the constant on the top. So it's c over a. So it's actually quite simple. So basically, and if you really got confused, you can also use the difference of the square to derive the result yourself with the quadratic formula. And yeah, so in summary, they especially you don't, if you haven't get very deep into, because quadratic is a huge topic in the school, middle school and the high school. Eventually you're going to see how it's being drawn, and the function shifting, they are horizontal shift, vertical shift, they are scaling, and they are compression, and they are dilation, and there are so many transformations. Function is a big part. We're going to talk about at some point. But function transformation is actually relatively difficult. But for quadratic, I think the easiest way to tackle is just formula. If you have the formula, you can always solve it, guaranteed to solve it. And plus the formula will help you to get to the Vieta formula. So basically, if you remember that story, that's all you really need to take at this point. And so let's get to the quadratic equation problems. And quadratic equation problems, actually, there are a lot of fun problems related to quadratic equation. Let's try to do this type of problems. And so a lot of quadratic equation is actually like infinite. This is an infinite root and looks extremely difficult, but actually extremely easy to tackle. Let me show you how. So this is a nested square root. How do we simplify it? In order to simplify it, we can just assume the whole thing will be equal to x. Is that right? So then we can square both sides. So if we square both sides, we got 6 plus square root of 6 plus square root of 6 plus square root of 6 plus dot dot dot. Because it just has infinite level of d, then this is x squared. And notice this part is actually exactly equal to the whole thing. So we can replace this part just by just x. So 6 plus x equal to x squared. So here we're going to solve this equation, quadratic equation, and this is going to be x minus square minus x minus 6 equal to 0. And this is a factorable. And so we're going to factor it. And how do we know factor? Let's try to, for example, if you really want to know if it's factorable, you can use the discriminant. So one of the things is square boy, ignoring for awesome check. So this is the discriminant. So here is the a is equal to 1, and the b equal to -1, and the c equal to -6. So basically, if you plug in those formula, and -1 square minus 4 multiply 1 multiply -6 is actually 1 plus 24 equals 25. So checks. This is a perfect square, so it's factorable. So this you actually can factor it fairly easily. You don't have to check it basically. This one you don't have to check it. But in case you had a more complicated thing, you are not sure whether or not it's factorable, go ahead to check it first. Otherwise, you might spend tons of time that doing a problem that is a dead end if you take that route. And so let's try to factor it. And this, so c equal to -6. We need to factor c so that 2 of the factor we add to b. b is -1. So factor -6 to make -1 is easy. It's just -3 and 2. -3 plus 2 going to be -1. So basically, this is an easy one. And it's going to be x minus 3 and x plus 2. And then basically, x1 equal to 3 and x2 equal to -2. Observe the whole thing has to be positive. So this is extraneous term. And so basically the whole thing will add up to 3. So that's the answer. So looks very strange, but you are able to solve it with the like quadratic equation. So this is another nested one. Let's try to do this one. And so this one, if we assume this expression is equal to x, then basically, if we just separate this part, the middle inner part, this part is also equal to x. So we actually is able to rewrite the whole thing into that 1, 2 plus x equal to x. And we can do cross multiplication. And this is just equal to, this over 1. And so if you do cross multiply is x squared plus 2x equals 1. Equals 1 is actually -1 equal to 0. So so here is a good example. You use a formula to solve it. A equal to 1, B equal to -2, and C equal to -1. When you use formula, always write out the coefficient explicitly. That will enable you to do it right and able to double check. And also the first step, just do it in the full scale and don't. And the first step, if you use formula, just recite the formula. So it's a -y is wondering whether or not going to a radical party and talking to square y, ignoring for all certain checks, and all over at 2 a.m. And here is at -b, and don't ignore anything, just negative. B is -2, so -2 plus minus, and here is b squared is -2 square minus, and minus 4. A is just 1, and C is just -1. Then all over 2a and 2 multiply 1. So this is, I think, if you are in lower grade, you might get scared about it. But, like student at Sharon level, definitely views this as normal. So this is not something really, disturbing. It's just a normal phenomenon of filling out a formula. This is how it works. And so basically, this is going to be like 2 plus minus, and this is going to be 4. And this is negative, negative, going to be positive. So this is plus 4. And this is over 2. So basically, this is going to be 4. And this is going to be 8. So a square root is equal to 2 over 2 square root of 2. So basically, and we have 2 and is all over 2. So basically, it's 2 plus minus 2 square root of 2 over 2 equals just, 1 plus minus square root of 2, because every 2 other 2 is canceled out. So this is the final result. So this is the final result, and we have to judge, if there are any, obviously, this seems to be only takes a positive, because these are going to the infinity. It's going to be positive. So x has to be a positive. And x may be positive. So basically 1 minus square root of 2, this is extraneous. So we are not going to take this one. So the answer is that 1 plus square root of 2 is going to be this one. Yeah. I did something wrong. Oh, here is where I did it wrong. It's actually b equal to just 2. So basically negative. So here, do you see that where I did make a mistake? I make a mistake, actually is wrong. So basically here is, how I get it wrong. Anyway, yeah. So if it is positive, then basically is actually minus. So but if I keep everything here, it's easy to double check, because you're able to double check that, each step. And so b equals 2. So this is 2. This is 2. And everything else, then basically, it's affect things here. So it's not going to be, it's going to be negative 1 plus square root of 2. So this is where, it's going to work. Anyway, so this is the way that we are going to do the quadratics. And then let's try to see some, like, let's try to see some Vieta. So in the contest, they actually do a lot of Vieta problems. So let's try to do some of those. Yeah, Vieta. So basically, let's do this. Yeah, let's try to do this problem. So this problem is that, the two solution of this is j and k. What is value of this? So this is a quadratic equation. So it's 2x squared minus 5x plus 1 equal to 0. So this is the full quadratic equation. And then it has two roots. So x1 equal to j and x2 equals k. And then basically, through the Vieta formula, we know that j plus k equal to negative b over a equal to negative, b is just negative 5 over a is just 2 equals 5 over 2. And then j multiply k equal to c over a equal to 1 over 2. So these are the condition we know. And here it's asking what is the value of j minus 1 multiplied 1 minus k. So this is actually equal to, we FOIL it, we're going to get j. And first order is going to be negative jk. And the inner going to be minus 1. And the last going to be minus going to be positive, going to be plus k. So basically is equal to negative jk. Let's reorder it so that highest exponent index comes first. Plus j plus k minus 1. So basically this is the expansion of this of the product of these two binomial. So here is actually, I can plug those number back in here. And negative jk is just negative 1/2. And plus j plus k is plus 5 over 2. So these two term is here. And minus 1. So basically this going to be, this minus 1/2 is going to be 2, because 4 half. 4 half is 2. 2 minus 1 equals 1. So basically the whole thing equal to 1. So this is typically what it's going to, what, you know, the Vieta problem set will look like. And yeah, this is even more simple. What is sum of the roots of this? Sum of the root is just, this is very straightforward, very, very straightforward. So basically, you know, a equals to 9 and the b equal to negative 7 and the c equal to 1. And the sum of the root is just negative b over a and equal to negative. And the b is negative 7 over a equal to 7 over 9 and equal to 7 over 9. So that's the answer. And so that's kind of what this look like. And so today we go through some sum and product. And so let's try to solve some word problem, quadratic word problem. So quadratic word problem is just like a normal problem, but just the equation itself actually yield a quadratic function. So that's all it is. For example, this one, let's go through it. And the product of two number is 9, and their sum is 12. Express their positive difference in simplest radical form. So the product, so basically, you know, if I have two root, yeah, so, and let's say R and S is equal to 9, and their sum R plus S equals 12, and express their positive difference in simplest radical form. So basically, you know, this one, we will just have to reconstruct we are able to reconstruct this equation by using these numbers. And so it's already told me the, you know, the difference of the root and the sum of the root. So I can say that this equation, if there's a radical, or if there is an equation looks, if there's a quadratic will yield those results, it has to be x squared. And the root is actually, you know, minus r plus s and plus rs equal to 0. So basically, you actually is able to derive this directly, x minus s and x minus r, because it's asking tell you those. So basically, if you expand it, basically, it's x squared minus s plus r x plus sr. So basically, if you have two roots, you can write it in this form, and this will use this and this. So basically, you don't have to remember anything. You can actually derive this to here directly. So you plug in here, so x squared, and this is their sum, the product of two number. And so their sum is 12, so minus 12 x and plus 9 equal to 0. So basically, this is the equation. And express the positive difference in simplest radical form. And the simplest radical form, basically, if you use the quadratic formula, basically, it's just 2 of the root is that negative b. This is, a equals 1, b equal to negative 12, c equal to 9, and negative b is 12. And plus minus b squared is just 144 minus 4ac, 4 multiply 9, and all over 2a, over 2. So basically, this is 24 plus minus. This is 144 minus 36, 108. So basically, this one is actually has a radical. It has a radical. So 108 divided by 9, 18 and 2. So it is 9 multiplied 12. 9 multiplied 12 is 9 multiplied 4 multiplied 3. So basically, this is actually 3 square multiplied 2 square multiplied 3. So this is 6 square multiplied 3. So this is 6 and 3 square root. So this is in this format. So this is going to be 12 plus minus 3 square root of 3. So it's asking the positive difference in the simplest radical form. Basically, positive difference. So one of the root is 12 plus 3 square root of 3. The other root is just minus 12 minus 3 square root of 3. It's actually, this going to be canceled out. 12 going to be canceled out. This is plus, minus going to be plus. So going to be 6 square root of 3. That's that is the, yeah. So this is just, the way that you can do the problems. And let's see. They actually have the solution, and let me get. So this is the solution key. This is the counting. This is the yeah. For example, this is the 1031. yeah, 1031, 6 square root of 3. So basically, actually, I got the right answer. So basically, this type of the problem, the Vieta related problem, it may not be very straightforward. It may not be very too easy. And but if you do the right thing, you will get it. And some of those, this is just some of the examples that not all the like quadratic equation could be factored. And just formula is absolutely necessary in most, if you deal with real life problem, I think it's almost formula has to be using almost every equation. It's actually, the factoring problem is much more of those actually designed problem. If you don't really specially design for it, actually almost 99.999 is going to be like need a formula. And so this one is the let's try to do one of the other problem. Let's say that Kendrick ride his bike X miles per hour to school and taking to get there. If Kendrick live 5.4 miles from school, how many minutes does it take to ride to school? So basically, it's a if you saw a speed distance problem, always write a table like this, because that's just if you have a fixed format, it automatically give you a huge advantage over other people, because you actually know exactly what to do, and other people have no clue, and they are not organized. If you are much organized, other people, you automatically gain huge advantage. So ride his bike X miles per hour. So the rate is X. And it taking X plus 15 minutes to get there. And so if the rate is X miles per hour, this is X plus 5 minutes, X plus 15. And this is minutes, also not hours. So but you have to divide by 60 in order to get the hour. And if lives 5.4 miles, so this is the time, see the distance, and the distance has to be 5.4. So how many minutes does it take to ride to the school? So this you just multiply. So x plus 15 over 60 and equals 5.4. And this is just, I think this is going to be a big number. We're going to x multiply is actually x squared plus 15x. And so 60 multiply 5.4, and that's going to be 300 if we do distribution. And 4 multiply 6 is equal to 24. It's plus 24. So basically that's, is equal to 324. So x squared plus 15x equals minus 324 and equal to 0. So basically, this is the, basically, this is actually, if this is format, you actually, best way is try to factor it first, because this is an integer, this is a monic. Monic usually is much easier to factor, especially this type of problem may be a design problem that, cater to the factoring. So we kind of just 324 divided by, obviously this is divisible by 9. So it's divisible by 9. And so this is 36. So 9 multiplies 36 and equal to 3 square multiply 6 square. So 6 square is actually 2 square multiply 3 square. So it's actually 2 square multiply 3 to the 4th. And so here here's a trick. So we have a common factor here. The common factor is 3, here's 3. So basically, when we factoring this type of thing, both factor has to contain a 3 in order for the middle term to add up to 3. So basically, we have to have a 3 on one of the factor. And obviously, those two has to be fairly close. If we just 1, 3, that's not enough. And this is like, if we have both 3 here, the rest of the factor is 2 square and 3 square. So we trying to distribute the remaining factor into those two factor to make the 15. And so, and the difference has to be, because 3 multiply 5 will get to 15. So basically, we're trying to make a difference of 5 between those factors. And obviously, we have to distribute 2 square and the 3 square, because that will make 15. Because 3 square minus 2 square is 9 minus 4 equal to 5. So basically, that will make, so basically, we already factor it right. So basically, we will be plus x plus like 27, because this is 27, and then x actually minus 12 going to be equal to 0, and this is actually will add up to positive 15. So basically, x equal to 12, because we are seeking for the positive solution. And if it is x plus 27, it's negative 27. It wouldn't make sense. So it will take, so how many minutes does it take to ride to the school? So this is ride his bike per hour, and it taking plus minutes. So basically, x is 12, and 12 plus 5, 15 equals 12 plus 15 equals 27. So it takes 27 minutes for Kendrick to ride to school. So that's going to be the answer. I think 1531. Let me check if I did it right or not. I have never done this problem, but these problems are not difficult. It's more about your capability. It's not about which problem it is. And yeah, it's 27 minutes. So basically, if you have a format, if you have a method to deal with those type of problem, you almost guarantee to solve it fairly confidently. There's nothing really going to block you. So that's about solving the problem. I think time is up, and we already like this is 104 minutes. We already passed 90 minutes on time, and we actually cover this topic, because we actually this class is more on the quadratic and Vieta. So basically, these are the sample problems. We go through a bunch, and using both Vieta and the normal, like either like formula or use the factoring. So these are pretty much about majority of the trick you would use in solving the quadratics. And just trying to do as much problem and bring your problem to the next class, so we will be able to deal with it. Okay, and have a nice evening, everyone. Bye bye.
Yeah.